Look at example 7. Here's an application of this unit circle stuff we've been dealing with. A lot of times I'm dealing with navigation of things and being able to describe to somebody where something is. We use unit circle ideas in that. The one thing I will say though, this isn't a unit circle. It says a circular area in a 4-mile radius, so this is not a unit circle. This has a 4-mile radius. So where we typically put the 1 for the hypotenuse, we're going to be putting a 4 for the hypotenuse on this. Beyond that, the technique is what it was. All right, so a rescue team searching a circular area in a 4-mile radius around their camp. The team travels on a path 30 degrees east of south. All right, so let's describe how that works. So 30 degrees east of south. So, which direction's south on this picture? Straight down, right? Which direction's east?
Right.
To the right. So if we're going 30 degrees east of south, that means if we're looking south and we look 30 degrees east, that's what they're talking about. So 30 degrees east of south means that we're looking at a 30-degree angle here. So again, south is straight down. We're looking 30 degrees east of south, so we got a 30-degree angle there. Okay. Using what we've been using so far in this picture looking like this with a circle like set on the coordinate plane like that, we typically draw a reference triangle to the x-axis. What we currently have is an angle to the y-axis. That's not going to be what we typically use. So, if I draw what I typically draw, which would be this right here, there's my right angle. This angle right here would be the reference angle, the one going from my slanted line to the x-axis. How big is that red angle?
60.
And how do we know it's 60?
Yeah.
The whole angle there is 90, 30 is being used down here, so there's 60 left over for there, right? But again, I always want that angle from my slant to the x-axis, not to the y-axis. Sometimes you're not given the correct angle. I use the word right angle, that's 90 degrees. Sometimes you're not given the correct angle, so you need to build the correct angle based on other properties. So we can see a right angle, we can see how big that angle is. So now, looking at this, we're looking at our origin angle. I know the cosine is this and the sine is that, right? But the cosine this time and the sine aren't those numbers because this isn't a unit circle. This is a radius 4 circle. Okay, but they're not asking for the sine and cosine, they're asking for the final position relative to their camp. Their camp is the origin. Okay, they're searching a 4-mile radius around their camp, so the camp is the center, the origin. They're going 4 miles around it. So how far east and how far south are they traveling? That's what we're asking for. How far east, how far south? So we're looking for, specifically, how far is that, how far is that? We know this right here is what? That slanted piece is how long?
4.
And why do we know it's 4?
That's the radius.
It's the radius of the circle, right? So going from the origin out to the edge of the circle is the radius. And our task is to figure out what x and y are. So what I'm looking at now is a 30, 60, 90 right triangle. So if I pull the right triangle out of the picture, 60 degrees is right here. That's a right angle there, which makes this 30 down here. This is 4, this is x, this is y. Okay. Now you have options on how to do this. You can use SOHCAHTOA, figuring out x and y with SOHCAHTOA. You could use your 30, 60, 90 right triangle ratios if you wanted to. Take your pick. Okay. So let's go with SOHCAHTOA on this. Do you want to use the 60-degree angle or the 30-degree angle? 60, okay. Then again, anytime you're going to use SOHCAHTOA, you have to make that decision. I'm going to use this angle, all right, because you have to identify opposite adjacent hypotenuse for that specific angle. So we picked the 60-degree angle because we wanted to. We could have just easily picked the 30. It doesn't make the problem easier or harder to pick one or the other. Just pick one, all right? If we're picking the 60-degree angle, which side's opposite 60?
Y.
Y is opposite 60. Which side is the hypotenuse?
4.
4 is the hypotenuse, which means x must be the adjacent side. We're using SOHCAHTOA. All right. I know the hypotenuse. I want to know the adjacent, so which trig function would I use? Cosine, right? I know the adjacent, I know the hypotenuse, want to know the adjacent, so I'm gonna use cosine. And if I wrote my trig ratio out, it's gonna say this, cosine of 60 degrees equals adjacent x over hypotenuse 4. Oh, go ahead. Track people can go. As you leave, if you close the door, I'd appreciate it too. Thank you. So, again, using SOHCAHTOA, cosine of an angle, the angle we chose was 60, equals adjacent x over hypotenuse 4. If we punch in cosine 60 in our calculator, it says 0.5. That's my calculator, so when I punch it in, right here, cosine 60 equals 0.5. Right? We cross multiply, so we're going to get 1 times x equals 0.5 times 4, which would be 2 miles. We're using a distance of miles here. We're talking about actual real-life things here, so we want to put units on our answer to represent. It's not, they're not just walking 2, they're walking 2 miles. If you say walk 2, that might be 2 feet. Walk 2 feet. Done. Right? Now we know how far east they went from their camp, 2 miles east. Now we want to find out how far south they went. So we want to find out what y equals. So if I want to find out what y equals, again, using SOHCAHTOA, we're using a 60-degree angle. We know the hypotenuse. We want to know the opposite. So what do we use? So sine, right? So SOHCAHTOA, so is sine. So sine of 60 degrees over 1 equals opposite y over hypotenuse 4. And using SOHCAHTOA, identifying things that you know and putting them where they belong. We punch sine of 60 in our calculator. Sine 60, it is 0.8660. Cross multiply, we get 1 times y equals 0.8660 times 4, which is 3.46 miles. So we're going 2 miles east and 3.46 miles south. Describe it using your normal north, south, east, west directions. How far east, how far south, how far west, how far north, whatever direction you're going. So again, draw the picture first to establish things, and then you can see very clearly, horizontally we're going east, vertically we're going south. We've headed off this way, horizontally west, vertically north. So again, you draw the picture to establish which directions you're going, east, south, north, west. You have to use trigonometry to find how far you went.